Hello and welcome students to the class of business statistics. In the last class we were just discussing about various sources to collect data. In this class we will discuss about the unpublished source, which is a part of secondary data. So there are various sources of unpublished data such as records maintained by various government and private offices, studies made by research institutions, scholars and etc. Such sources can be used wherever necessary. Before using such data, the investigator should consider the following aspects. First one is suitability. Before using secondary data, the investigator must ensure that the data are suitable for the purpose of the inquiry. The suitability of data can be judged in the light of the nature and scope of investigation. Second is adequacy. If it is found that the data are suitable for the purpose of investigation, they should be tested for adequacy. Adequacy of the data is to be judged in the light of the requirements of the survey and the geographical area covered by the available data. Third one is reliability, which specific method of data collection was used. Were the enumerators capable and properly trained? Was there a proper check on the accuracy of field work, etc.? Now, there's a difference between primary and secondary data. The difference between these two data is only of degree. Data which are primary in the hands of one become secondary in the hands of another. Data are primary for the individual agency or institution collecting them, whereas for the rest of the world they are secondary. A few examples would clarify the distinction. Suppose an investigator wants data about the spending habits of the students of Delhi University. If he collects the data himself or through his agents adopting any suitable method such as contacting and interviewing students or circulate a questionnaire, the data would constitute primary data for him. On the other hand, if the students union has already made a similar survey and the investigator obtained data from union office, such data would be constitute secondary data for him. Similarly, statistics collected by various departments of government such as Labor Bureau, Central Statistical Organization are primary for the respective departments, whereas for all others they are secondary data. Now, here the data is completed. Okay, we have discussed two kinds of sources. In these two sources, there are different methods to collect data. Now, we will discuss about the graphical representations of data. Like after you collected the data, you should represent it in a graphical form so you can read all the data at once. A large variety of graphs are used in practice. However, here we shall discuss only some important types of graph which are more popular. Broadly, various graphs can be divided under the following two heads. Graph of time series, graph of frequency distributions. Constructing charts and graphs is an art which can be acquired through practice. There are a number of simple rules adoptions of which leads to the effectiveness of the graph. However, before discussing these rules, the elementary procedure of constructing a graph is considered. Then construction of graph, like how would you construct a graph? For constructing graph, we make use of graph paper. Two simple lines are first drawn which are intersect each other at the right angle. The lines are known as coordinate axis. The point of intersection is known as the point of origin or the 0 point. The horizontal line is called the axis of x. The vertical line of the axis is called y. The alternate appellations are x-axis and y-axis respectively. It is conventional to take the independent variable on the horizontal scale and the dependent on the vertical scale. In case of time series, time is represented on the horizontal scale and the variable is representing on the vertical scale. For each axis, a convenient scale is chosen which represents the unit of a variable. The choice is made in such a manner that the entire data is accommodated in the in the space available. The scale on x-axis and y-axis need not to be identical. After the choice of the scale is made, the last step in constructing a graph is to plot the given data by taking the corresponding values of x and y. The various points so obtained are then joined by line segments. This is the construction of any graph. Now, in the graphical representation, we are having four kinds of graph. First one is histogram, second is frequency polygon, third one is smooth frequency polygon, and the fourth one is ogive, that is cumulative frequency curve. So let's start with histogram. While constructing histogram, the variable is always taken on the x-axis and the frequency is depending on the y-axis. Each class is then represented by a distance on the scale that is proportional to its class interval. The distance for each rectangle on the x-axis shall remain the same in case of the class intervals are uniform throughout. If they are different, the width of the rectangles shall also vary. The y-axis represents the frequency of each class, which constitute the height of its rectangle, which is also called as bar. In this manner, we get a series of rectangles, each having a class interval distance as its width and the frequency distance as its height. The area of the histogram represents the total frequency as distributed throughout the classes. Just for an example, here is a table in which the following table gives the lifetime of 400 neon lamps. Now we have to draw an histogram based on this table. So here the class intervals are given just like 300 to 400, 400 to 500, 500 to 600, that are called hours. Then there are number of lamps which were lighting in these hours, that is 14, then 56, then 60. So it is kind of a frequency of these class intervals. Now, as per the construction of graph, you should follow all the steps. Like in the x-axis, you will always plot class intervals. On the y-axis, you will always plot the frequency. And then you can draw histograms just like from 300 to 400 there is a bar on in which the height is 14. Then in between 400 to 500 there is another class interval and the height is 56, then 60, then 86. This is how you are going to draw a histogram, but you should know that in histogram the bars should be connected to each other. There should not be any gaps between the bars. Okay, now sorry. Next is frequency polygon. Frequency polygon is a graph of frequency distribution. It has more than four sides. It is particularly effective in comparing two or more frequency distributions. There are two ways in which a frequency polygon may be constructed. First one, we may draw a histogram of the given data and then join by straight lines the midpoints of the upper horizontal side of each rectangle with the adjacent ones. The figure so formed is called frequency polygon. It is an accepted practice to close the polygon at both ends of the distribution by extending them to the baseline, which is x-axis. When this is done, two hypothetical classes at each end would have to be included, each with a frequency of 0. This extension is made with the objective of making the area under polygon equal to the area under the corresponding histogram. The readers are advised to follow this practice. Another method of constructing frequency polygon is to take the midpoints of the various class intervals and then plot the frequency corresponding to each point and to join all these points by straight lines. The figures obtained would exactly be the same as obtained by the method number 1. The only difference is that here we have not to construct a histogram. So there are two ways, with the help of histogram and without the help of histogram. By constructing a frequency polygon, the value of mode can be easily ascertained if from the apex of the polygon a perpendicular is drawn on the x-axis, we get the value of mode. Moreover, frequency polygons facilitate comparison of two or more frequency distributions on the same graph. Just for example, here is a frequency polygon. So again, there is a class interval and then number of students, which is frequency. Now, you can just make a histogram, then connect all the midpoint of these rectangles. And in the end, you can just connect these two last points to the x-axis. So you will see a histogram just in the red line. Okay. Second one you can do is, firstly, you have to find the midpoints of the class interval. Now, how will you find the midpoint? So you have to just add all the class intervals, like for example from the first class interval the values are 140 to 150, so you should add both these ranges like 140 and 150. So 140 plus 150 and then just divide it by 2, so you will get your first midpoint, that is 145, then 155, then 165. uh, After getting these midpoints, you have to plot the frequencies on the graph and then connect it with line and with the help of scale as well. Okay, after that you will see a histogram. Thank you.